This investigation synthesizes academic literature, industry reports, and policy documents from 2020 through 2025 to map how artificial intelligence is rewriting semiconductor supply chain risk management. The analytical framework integrates three domains: technology adoption of generative AI and digital twins, corporate resilience investments, and national security regulations shaping industrial policy. Tower Semiconductor secured a $3 billion METI-backed expansion in Japan targeting silicon photonics and silicon germanium production for AI data center infrastructure. This move repositions mature node capacity at the center of AI infrastructure, shifting procurement focus toward photonics-enabled interconnect solutions. Analysts warn the concentration of photonics supply in a single geographic expansion raises strategic vulnerability questions for data center operators. TSMC capital expenditure is projected between $52 and $56 billion for 2026, a sharp rise from $40.9 billion in 2025. The foundry leader began mass production of 2-nanometer chips in the fourth quarter of 2025, marking the most advanced logic node in volume manufacturing. Advanced packaging capacity, specifically CoWoS, is expanding 58% year-over-year to relieve the bottleneck choking AI accelerator shipments. Transactional risk now surfaces deal by deal and shipment by shipment, with no contract fully anticipating the dynamic disruption landscape. A supply chain director at a major semiconductor company reports critical equipment lead times stretching beyond 2 years, threatening production line continuity. Material shortages are forcing the industry to fundamentally rethink risk management and build structural resilience into every supply tier. While headlines focus on generative AI, a quieter crisis unfolds. NAND flash demand is accelerating past the industry's ability to supply it, driven primarily by AI workloads. Supply chain leaders are deploying scenario-based planning systems that evaluate multiple disruption and demand conditions simultaneously. Predictive analytics and digital twins now model fab throughput, logistics flows, and geopolitical shock scenarios in real time. AI-driven forecasting tools ingest equipment lead times, capacity ramps, and policy shifts to generate probabilistic supply outlooks. K-Wave Media, traded on NASDAQ under KWM, signed an exclusive letter of intent to acquire a controlling stake in a South Korean semiconductor materials company. The deal targets 50% plus one share of a privately held developer and manufacturer of semiconductor materials and specialty chemicals. The company's net loss narrowed 278.1% year-over-year, signaling a genuine turnaround trajectory. Intel's 9% CHIPS Act equity stake has appreciated on paper, while NVIDIA, Microsoft, Amazon, and Apple have all opened foundry talks. Despite the interest, Intel does not expect meaningful foundry revenue before 2027, highlighting the long gestation of advanced node qualification. Marvell presents a contrasting picture. Net income fell 80.6% year-over-year despite 27.6% revenue growth. The custom silicon suppliers' margins are being squeezed by ramp costs even amid strong AI demand, exposing the economics of volume scaling. Resilience investments now prioritize multi-source qualification for critical materials, reducing single point of failure exposure across the supply chain. Digital twin implementations in leading fabs simulate equipment maintenance windows, yield excursions, and capacity reallocation under disruption scenarios. National security regulations, including export controls and entity lists, now directly dictate capacity allocation decisions for advanced nodes. Industrial policy incentives in the US, Japan, and Europe are reshaping the geographic footprint of mature and advanced node manufacturing. Mature node capacity is being repositioned from pure cost optimization to strategic infrastructure supporting AI data center photonics and power delivery. Advanced packaging bottlenecks, particularly in high-bandwidth memory integration, are being addressed through coordinated CapEx across OSAT and foundry partners. Silicon Analyst breaks down the fab economics of Tower's photonics expansion, highlighting the cost per watt advantage of silicon germanium for optical interconnects. The broader mature node supply landscape faces concentration risk as photonics capacity consolidates in METI-subsidized Japanese facilities. Management frameworks now require continuous monitoring of equipment lead times, raw material purity specs, and geopolitical flashpoints simultaneously. Predictive analytics evaluate multiple disruption conditions, from natural disasters to trade restrictions, across thousands of supply nodes in parallel. Demand forecasting under AI acceleration incorporates hyperscaler capital cycles, model training schedules, and inference deployment curves. South Korean semiconductor materials and specialty chemicals represent a critical choke point for global fab operations, driving strategic M&A activity. Specialty chemical supply chains lack redundancy, with single-source dependencies for high-purity etchants and photoresist essential to advanced lithography. The optimal resilience mix combines scenario-based AI forecasting, multi-source qualification, geographic diversification, and policy-aligned capacity investments. Corporate strategy must balance the 78% CapEx surge at leading foundries against the 80% margin compression at custom silicon suppliers. As AI infrastructure demand rewrites semiconductor economics, the winners will be those who treat supply chain resilience as a strategic asset class, not a cost center.